So I'm going to ask you two questions which I want honest answers. Number one, who loved science or chemistry at school? Oh, okay. And who loves robotics? Oh, well, okay, well, we're going to try and talk about both of them together. So I'm going to try and talk to you today about a vision that's been developing in my lab for the last 5 years now, and we want to talk about one specific problem, which is how can we put chemistry to the top of our agendas, but more importantly, chemistry into everyone's house, into everyone's kitchen. We already have chemistry in our kitchens if we like cooking, but how can we make medicine and diagnostics available on a much broader scale? But perhaps more importantly, how can we make drug discovery shorter? And how can we make these drugs more available? And the idea about using chemistry and computing together is to try and think about how we could program with this chemistry. I think there must be lots of programmers in this audience. Lots of people love hacking, love using software, compiling, making web pages. I want to make chemistry as sexy as hacking together web pages. But is this going to be tough? The thing is that computing is universal. In fact, more people speak the language of binary, or more cultures and more devices than any other language in the world. So you imagine the language of computing is binary, and that is made by software being compiled to that binary. And that binary code can be run on silicon chips, and now cheap Arduino boards are used in 3D printers, drones, robots, and hackers are having a lot of fun turning this software and this hardware into a new way of hacking. So I wanted to ask the question about how we could do this in chemistry, and could it change the world in which we live? And the problem about having universal chemistry is that chemistry is quite hard from a pharmaceutical point of view. If you think about the pharmaceutical industry today, they have to use very complicated machines, many hundreds of chemists to develop drugs. And I wanted to ask a question, does it need to be like this? Can we make chemistry universal and give universal access to medicine? And obviously this is quite an important point here in India, to get access not just in the big cities, but in the villages, out in the middle of nowhere. Instant access at the point of need. The big issue that goes with this is that drug discovery right now takes 15 years to solve a new problem. And even worse than that, when the drug company starts making the new drug, maybe they'll only make it for 5 years or 10 years until a posher version comes, and then the manufacturing facility is deleted, and that drug is no longer available. So could we make this drug available for all time, the same way that MP3s allow you to get access to all of the music library? So this is a question that we wanted to also answer. Now, chemistry looks quite hard, but it's really quite easy. It's just like Lego, adding atom onto atom, molecule onto molecule. And in the background, you can see a very large molecule called Taxol. This is one of the best anti-cancer drugs known, which is fantastic. But the problem is, there's less than 1 kilogram on the entire planet that we can access. It's actually a natural product you get from a tree. And the problem is, it takes 200 steps for a chemist to make this molecule. Huge amount of time. Maybe we could be able to app that. Maybe there's some way of making that easier. So we tried in my lab, wiring together all these chemistry experiments and making all these complicated tubes to move molecules from here to over there, adding solvents, boiling, cooking, boiling. And you can see that it becomes a bit of a mess. But if you then go to a simple laboratory and more complicated laboratories like you see up behind me, I wonder if we could think about chemistry like a software problem. So what do I mean by that? Well, lots of you write code, and you can write code in very simple programming languages, and then you reduce that code to an executable file. And that file runs on the platform. You wouldn't dream of running an executable file made for a PC on a Mac, and vice versa. You wouldn't do that. The computer would say no, blue screen. But in the chemistry lab, of course, you can do it. And chemists have been having problems for years reproducing each other's work. So what we tried to do is to come up with a programming language for chemistry that could make chemistry portable, modular, and reproducible. And in the same way that you copy code, who here copies code for their programs from the web? Yeah, some people, I reckon a lot of you do. And it's a great way to code. You copy the code, add it together to do what you want. Now, how about if we could do that in the discovery setting to make new drugs? So I said this to my team. I said, I want to make a way of programming chemistry. And they said, but we need a device to program the chemistry with. And I said, fine. Why don't we just make some nice programmable robotics? Can anyone guess what we're making at the back there? Yeah, you can see it's a basic time-lapse photography over 2 days of my chemistry team building 2 3D printers. Now, this is just start of the story, because 3D printers, as you well know from the lovely talks today, that you can use them to print plastic objects very quickly. So what about if we could use the 3D printer to print the test tube, or to print the reactor in which we can do the chemistry? Now, the next step is then to use the 3D printer to feed in some molecules and get out a new molecule. So it's really like a robot that would do the chemistry for you. So if you're scared that I'm going to make you do chemistry in your homes from a textbook, don't worry. The idea is to have a purpose-built 3D printer that would do the chemistry. So how would this work? Well, what we've been doing in my laboratory is we've been taking standard 3D printers and rehacking them so we have a 3D printing part that does all the plastic part, and then adding on a chemistry part with syringes so we could play with the chemistry and start to do new steps for reactions. But really, this is not the end. This is just the beginning. It's okay to have some hardware, but we need some software, and we need a way to wire the software and the hardware together. The transistor is the fundamental building block of the modern computer. Discovered over 50 years ago, you now have 1 billion transistors in the processor. So 50 years ago, the concept of a processor was realized conceptually with the transistor. But it wasn't possible. In fact, you'd need to fill an entire football pitch with valves and use all the energy that the world outputted to make this processor work. But today, they work. So what we're trying to do is to make a universal unit of chemistry, a very small reactor that does every step that we want and we can wire together. In the same way you could wire together your transistors to make a mobile phone, could we wire together the chemistry units to make a universal chemistry device, a bit like an all-purpose fabricator for molecules, materials, or diagnostics? This is the fantasy. So we've started to do this in the lab, to take this complicated chemistry and then to take the reactor and then the software, and we had to build a software code that would be universal. We had to invent the binary and the software. So the reason for thinking about in these different terms is we need to make chemistry available not just in my lab, but every other lab. Imagine Taxol, this molecule that's very, very rare, that we found a shortcut in my lab to make. But we couldn't make it anywhere else because my secret recipe was encoded in the laboratory, or the student had a secret thing they added. This would not work everywhere. So we needed to overcome these problems by using a software approach to the creation of new chemical entities. And the result of this could be quite profound. So the idea is to take all of chemistry and put it in a box, and then use a 3D printer to make the reactor. But then the 3D printer switches role and becomes the chemist and adds in the chemicals into the device. So now the 3D printer has 2 roles. It's a fabricator, but it's a robot, and it handles liquid. And you could go a step further. You could think about using the 3D printer to make tissue. And if you could then combine making plastic, making chemistry, making tissue, maybe you could treat disease in a different way. So let's just pause to think about what that would mean for diagnostics. Now, the lovely thing about technology today is people are sharing software and hardware. And so if I build a certain hardware in my lab, say a 3D printer, there'll be a piece of software I can download to make a different shape. And all I need is that data. And that's something that we should think about. So what would this mean in its entirety? Well, maybe one day you wouldn't need to go to the chemist to buy the drug or to the hospital. That you could just download from your mobile phone, from the internet, the coordinates you need and put them into your printer and press print. Then so maybe you could make your own headache pill. Or maybe you could then think about destroying the pharmaceutical companies. But maybe, no, maybe we could actually use the pharmaceutical companies to then suddenly release all the old drugs into a new market. So there was availability over all the cost scale. So the model changes. Now think about counterfeiting drugs. Lots of drug companies, generics, are falling victim to this, that you get your malaria tablet and you take it, but you realize you've been sold an antibiotic. If we suddenly put the value into the software and the ingredients were cheap, you would get rid of this problem. So the idea would be to take the very cheap inks that are available, very cheap chemicals, and by combining different steps of chemistry in the robot, you could make these new drugs. So you'd be able to app chemistry. You go to your chemical app store and you'd buy the legal medicine you would need. Now, of course, this is a very long and grand vision, but before you just dismiss it, I would ask you to go back to the transistor. The transistor is well over 50 years old, and we didn't get computers for 20 or 30 years in our homes, but they existed in other places. So maybe firstly, the 3D printing system will be in a lab, in a biochemistry lab that doesn't want to go to all the trouble of making complex organic molecules because they want to check with DNA. But one day, it will be in your home, I guess. But what would it really mean? So you could print your own medicine. So you would have apps for medicine. You could then download the diagnostics. Say a new disease emerged someplace remote, in a village somewhere where roads, air transport wasn't available. You would download the diagnostic tool, print it, and then try and work out what had happened. You could then print drugs where they are needed. Now, I have this fancy picture here. Astronauts going to Mars. India is taking part in the space race as well. But maybe, if we're in a remote village, that would be even more important to be able to download the drug that you needed, where they're needed at the time. And then one day, and this is the thing that fascinates me, if we could take cheap genomics and work out what type of genes you have, what type of pathways are turned on and off, you could tell your own drug fabricator, and rather having to be beholden, dependent upon a pharmaceutical company that made just one drug for an entire population, we could make one drug just for you. And that's the idea that I want to leave you with. Thank you very much.